I don't hear you.
I didn't say anything. Can you hear me now?
Yeah, okay.
Yes.
Welcome, Gunnar.
Welcome. Hi.
Thank you for being here.
Many thanks for the invitation. I'm glad to be.
I hope you'll enjoy this meeting. It's uh, an honor for us to have you here. Um, so we can start talking about yourself, talking about the Vampire Project. It's
Sure.
okay for you? Ok, adesso vai nella prima slide.
Come dici? Vado con le slide?
Sì.
Ok, remember the keyword buggy boy is for the next slide.
Buggy Boy, ok. Okay, Gunnar, can you talk about yourself? What's your Amiga experience in the past?
Well, I started like many others also Commodore 64.
Okay.
Was of course very impressed when the Atari ST and shortly after the Amiga 1000 came into the shops. And the Amiga 1000 was a dream machine at that time, right? You could do everything with it. Was unbelievable if you were used to a Commodore 64.
Yeah.
So I had the luck that my parents actually were gambling and they went to a, how you say, casino.
Oh,
And played
Yeah.
and then I got an Amiga 1000.
wow. That's a very lucky.
Yeah. I mean, it was very expensive at that time. And yeah, so I started early with an Amiga 1000. And I also had the luck that I was at that time young. I was like 14 years old. And, but I had older friends in the Commodore 64 scene, which were pretty much experienced in removing copy protections and were swapping floppies over the ocean with Americans and so on.
Yeah, wow. You the crack through, the crack scene.
The cracking scene, yeah, the unprotection scene.
And protection scene.
And,
We have an expert of cracking and the machine here. He will be happy to hear about your demo scene experience.
well, I have the luck that these older guys already before me jumped over to the Amiga, so they had an Amiga 1000 as well, and so they kind of got me into the team, and because of their swapping, they had source codes of early intros, demos of the early cracking crews in the mid 80s, and that's how I started to learn 68K assembly, how I started to learn to understand the Amiga. This is how everything began for me, and I was with the Amiga till the very end. My last Amiga was in 4000, which I bought, well, when it came out. And yeah, on this 4000, I continued to work very long. Like when others had PCs with,
Any next generation Amiga?
I continued to use the 4000 till basically nearly the year 2000.
Oh,
And well,
so
because
you never used Morphos or Amiga One?
I actually had good contacts to build back from the Genesee, and I know the Base 5 guys, they're Germans as well. So, I mean, everything kind of started with Amiga 1000 for me, because I learned a lot of programming. Then, after doing my military service, I worked as a programmer for a company. But basically, everything was self-taught from the Amiga 1000 times. And I then worked in a company which did PCB stuff, hardware production, and there I learned what I now use in the FPGA, those development languages like VHDL. And from then I started working for IBM, and so there were a few other jobs between, but at the end I ended at IBM at the time when IBM was developing the cell chip.
What year about?
Let me think, 2008, something like that.
This was maybe the start of the FPGA projects on or FPGA technology was already here, already there when you started working on FPGA.
I started working on FPGA in, I think, 1999, something like that. So this is now 21 years ago or so. So time flies. And when I was working with IBM, the funny thing was the team there, the cell project team at IBM Böblingen, was full of ex-Amiga guys. So in the team where we were building cell-based blade centers, so these blade machines for high-performance computing for IBM, and our team was involved in building the at that time fastest computer of the world, Roadrunner it was called, for Los Alamos in USA, also cell-based. But the funny part was that a number of guys in our team were ex-Amiga guys. So Jens Künzer, which is still in our team here for the team, and Thomas Hirsch, and me, and a couple more. And we were all ex-Amiga guys, so it kind of happens we found the topic at lunch and talked about Amiga a lot, and when we were writing software for PowerPC and...
You talked about Amiga working with IBM. It's a strange thing.
Yeah, in our lunch breaks, right? We discussed, oh, this is a shit development environment. It was so much better on the Amiga, and it's a lot of stuff like that. And Thomas then told us that he did develop the AGA chip in the FPGA, and at that point of time he was wanting to revive the Amiga. So he was working with this for a very long time already. And Jens and me and Christoph said, we're going to help you. This is a great idea. We all love Amiga, and frankly, I was kind of heartbroken since Commodore died. You know, I started my career with Amiga, so to say, seeing how the select games and how they wrote trainers and these kind of things. That's pretty cool. So I tried to learn this, and learning how to unprotect some games or add some features. And I always also wanted to develop games. I actually wrote a few tiny ones. And when my big plan to start a career as game developer, which I wanted after my military career to start, was going to happen at the same time Commodore died. So this totally ruined my life plans. And I always felt sorry because, I mean, really liked the Amiga. The Amiga was to me something very special. It was
It's special for everyone who
yeah,
touched the Amiga
it was
in the 90s, in the late 80s and the 90s, I think.
right, right. It was. I mean, the programming was. Um, you could do unbelievable things compared to other machines, and the 68K made it possible that I could read my assembly code still and understand it. Which, when I look at the PowerPC stuff that I did for IBM, it's a nightmare. You, it's like. I mean, the others always said it's a punishment for people who killed their parents.
More you understood other architectures and more you liked the 68K.
Yeah, exactly. I did develop for Intel. I did develop for PowerPC. I did develop for ARM. I did develop for a number of different CPUs over the years, and every one of them, if I compared them with the Amiga 68K, made me feel more sorry that Amiga was there, right? So Thomas' idea to revise the Amiga really started a fire in all of us to say, well, that's a wonderful idea. Let's try to help him. Let's try to make it happen. And so the whole project started. And
It's you're talking about the Natami project.
yes,
Okay.
yes.
Alessio, change the slide. Thank you. Okay, this is more.
Oh yeah, right. You have here an old picture of basically all the IBM guys sitting in Peter's home. Peter is on the very left side. Yeah, this guy, and we are at his place at home, and
This
I mean,
this was the Natami team.
yes, this was the Natami team.
Okay. And Thomas Hurst is the one on the right of you.
Yeah, that's Thomas. Yes,
Okay.
and still in Apollo team is a guy in the black T-shirt on the very right. This is Jens. So,
Okay.
so he's
This Jens is still on Apollo team.
yeah, he's one of the power developers who invented some of the, or worked on some of the power development of the power curve of IBM. Yeah.
Natami was a very interesting project. I followed it.
Yeah.
It was very, very interesting.
You're right. I agree. It was planned as the Amiga, which never happened, right? It was a small PCB, a small mainboard, but it had everything. It had video in, video out, audio in, audio out. It had PCE connector, so you could plug in Voodoo or whatever card. It was very, very lot of and a lot of at the time very modern stuff in it. And
Yeah.
when Thomas started this design, it was clear he had a CPU slot, so you could plug in a CPU module. He produced an 030 68K 030 module. He produced several modules for the 060, one for the PIN version and one for the FE version, which you solder directly on the module, which you this is a special casing of the 060, which we could get reasonably from China at that point of time. But it was clear that all these 060s were either refurbished or leftover stock pieces, and there was no way to.
So Natami, excuse me, Natami was FPGA AGA implemented and Motorola 68K real.
Yes.
Okay.
So it was basically at the same time when Dennis did the Minimic design. So Thomas in parallel did the AGA design, completely independent from each other they worked. And Thomas used, of course, the existing Motorola CPUs, which were good, and but it was foreseeable that with not being able to buy new CPUs, you can't revive Amiga. So Bill Buck tried to help us. He arranged a meeting with CEO of Freescale at that time, and we had a nice meeting with these guys, and they were very friendly.
Okay.
They told us crystal clear, the cat which once produced those 60 is gone. The plans are gone. The original team which did this is, I don't know, the pension homes or something, and they have absolutely no possibility to produce a 60 for us, even if we put $1 million on the table.
This was the year 2008, 2000.
Around that time. I have to look at my calendar. It's long ago, like 13 years ago.
So 060 revision 6 was rare even back then.
Yeah, it was completely idiotic to plan something with this. I mean, it was clear we could get 100 or 200 or maybe 300, but you can't provide Amiga with 300 or 500 CPUs. We planned for more. We planned for 1,000 machines. And so that's why we talked with Freescale. You know, Freescale, the company after Motorola. Motorola's development was at that time called Freescale. So they should have the possibility to revive 060, we thought, but they said it's impossible with our budget. So, I mean, if we would have $100 million, maybe it would have been possible, but not with 1 million, they said.
Because the production was already dead.
Yeah, they produced since many years now, 060s no more. They have not anymore the tap in production, and already they basically have killed the coal fire as well.
Mm.
So they
tried to sell you cold fire.
I knew coal fire actually very well because I used to have good contacts with Freescale from different projects. I helped them in another project. I was involved in another project where I was testing one of their ships, which was actually used in the Ithaka mini Morpho-S machine.
Yeah.
And at that time, I also found like a small bug during this testing. So I had a few relations with Freescale in some projects, and Bill Buck also helped a lot. He had extremely good contacts to the Freescale guys from his Pegasus development. So actually our discussion was on a high level with important people, and they were very, very friendly.
Okay.
But it doesn't help. So
okay.
They can't
no way.
No, I mean, there's always a way, right? If the U.S. government comes with a big bag of money, everything is possible, but
okay.
it was not possible.
Okay, so you decided to build your own 68K?
Well, first we tried to use the cold fire, to be honest, because we know from experience that building a CPU is a huge task. It's more work than building a house. So we got some cold fire cards from Freescale, and we looked into using them because the cold fire, as you know, it can reach a relatively high clock compared to the 060. It supports only a subset of the instructions, but we thought if the number of used instructions is relatively high and you only need to emulate a few, then paying extra here, this slowdown will be compensated by the higher work rate. And I also knew the other Coldfire ship, which is not officially on the market. You know, you can today buy the Coldfire 4.
But the new Coldfire was different from the one you worked on?
At that time already, there was a Coldfire 5, but Freescale officially neglected to have it. But they have it. And I knew that they have it because I was involved in some of the GCC compiler tunings for it. So, so we knew
it existed.
we knew it existed even if they officially claimed they don't have it, because this was a company decision, and somehow, somewhere in high management decided that they don't want to go this route anymore. But we were confident if it was good enough for us, then we could use that. Anyhow, long story short, we tested the Coldfire, and we came to the conclusion it's not good enough for what we wanted. It was working, but the memory performance was a little bit disappointing to me. For me, memory speed is very important, because in all the stuff we did at IBM, I learned memory performance is what at the end makes a difference in real-world applications.
Yeah.
These gigahertz or whatever, these are numbers like we have on I don't know, on a card game or so. Yeah, my car has so many PS or something.
Yeah, but memory is a bottleneck.
Memory in the end is a big bottleneck. So I was always keen on having a machine with good memory speed. So also Thomas on his 060 CPU cards, he put cache chips like you have on a PC, like on a Pentium 2 or so module. You have these second level cache chips. So you have the same cache RAM chips also on this 060 board, which would have allowed it to have 2 megabyte second level cache, which is pretty awesome. Right?
Okay.
And so we thought, yeah, we need something with good memory speed, and the Coldfire didn't really do it. And it had simply our visible number of benchmarks then, and we disassembled the kickstart, we resourced it completely, we ran statistics over the whole kickstart, what type of instructions are in there, and made some charts and figured how many of those are supported by the Coldfire and how many of those would create these emulation traps, which are really slow. And we did the math and we said it sucks. Coldfire cannot be used with existing software on Amiga to a satisfying degree.
Coldfire is used on Atari ST.
The Atari guys have the new machine which runs MU.
Fire B, something like that.
But the difference here is their operating system is in C and it's open source, so they can recompile the whole OS to only use the instructions.
Okay.
I was in the team working on Ava, the Amiga web browser at the time, and I also made a version only for the Coldfire during the period which we did these Coldfire testing. Long story short, we figured the Coldfire isn't worth the effort. It's not good enough to replace an 060. Okay. And then we did what you said.
You aimed for 060 performance.
We wanted higher than 060 performance, and we didn't get this reliable with the Coldfire. And
was not good enough.
It's a mixed bag. You have, in some instructions it's good, in some it's slow, and if you look at the complete mixture, what the Amiga OS uses, the line was below the 060, a lot deeper, and we figured, well, this is no point. You can't revive Amiga with this.
Okay. Yeah.
And so we then said, fuck it, we need to develop a new core, and that was a project for me basically really turned on. Jens and me, we used every lunch break and every coffee break and every possibility at work to talk about how to develop a CPU which really rocks, and we had a lot of ideas. And yeah, that's how it started.
Alessios, cambia la slide, per favore.
Buggy boy, it's the keyword.
Okay, Buggy Boy. You can continue, Gunnar. You were talking about the 68 or 50?
Yes.
Okay.
We called it 050 at that time because we started with less features than the 060. And we first wanted to get it running single scalar, so one instruction per clock, but this is really fast. And then we wanted to, if this is working, we wanted to add in more pipes to have more instructions per cycle. So our code name was 050 at that point of time.
Okay.
And yeah, somehow, I mean, the Natami project, or let's say it's the other way around. When you have an engineer's heart, I think I have one, then you're always an optimist, and you always look at, you find stuff which is technically cool, interesting, right? You like the cool ideas in the Amiga, you like the great ideas, the blitter, the copper, DMA channels. I'm very fascinated by all these good ideas. And also, when I see good ideas in the operating system, like the data types and so, I say, wow, that's a clever idea. That's a real engineering masterpiece. Smart guys did this. I love this. So I like all these fancy, cool ideas. And so were the whole team in the Natami team were guys like me, liking cool ideas.
Okay.
And we didn't have any finance guys there, or those production guys which are bean counters and say, well, we need to meet the timeline, which cuts the ideas down to something reachable for a certain release date. So we were all guys with crazy ideas, plenty of them, and in love with good ideas. And no one putting the foot on the brake and saying, hey man, how about we look for something which we can do in 5 years, not something in 50 years? So
it was a realization of a dream for all of you.
Too much dream, too much vision, too much hope, and not enough pessimism and realism. So the Natami was totally overscaled in every aspect. Thomas he developed his own PCI core. He didn't buy a PCI core from Intel or so. No, he wrote his own. And this was cool, right? But he did it on his own. So everything was done on its own. And it needed to have also video in, so you could plug in a TV signal and it was scanning it, so digitizing. So he wanted every feature on Earth.
Yeah, I remember it was a full-featured Amiga.
And the crazy stuff is, if you develop something like such a computer, everything needs to work. If you have 99% of features, but the fucking mouse driver is not working, you can't sell the thingy.
Yeah.
Like, if something else like the IDE is not working, you can't sell the thing, even if the whole rest is working. So by having such a big thing with so many features, he had Ethernet chip and everything, you ended up with so many fronts, so many battles you have to tackle at the same time, that at some point realism kicks in and you start, ooh, you feel like, Second World War or something. Each battlefield from Africa to Norway, and then time starts to tick. You solve this, you solve that, but you have still 25 more things to solve. And time continues, and you have still worked for 2 years on it, and it's not sales ready. And
at what percentage of completeness was an Natami at the end?
Well, Thomas produced, I think, a dozen. I don't recall if it was 10 or 12, something like that, which we used in the team for development. And they all ran Amiga OS. They all could boot from floppy. They all could boot from HD, hard drive, or CF. They all mouse, keyboard, joysticks, everything was working. You could play Genesis or whatever on them. A few games had some minor, let's say, visual glitches here and there, as the chipset has some minor difference to the original. but in total it was usable. It was very much a usable machine.
I remember I have seen some videos of the Natami board. It was maybe a developer board that was given to the Natami members.
The members had boards. Yes, the problem was, or let's say problem at that time, we believed we want to revive Amiga, and some of us, like me, had a silly idea. We need a entry-level machine like the Amiga 1200 was from a price point of view, and the development board with all these features was very expensive, right? So we figured we can't sell it without making a loss for less than maybe 700 at that time. I mean, if you look back now, it's a steal. But
yeah, it's a good price point if you compare it to the Amiga 1X 5000.
Yeah, but we thought it's too expensive, and we thought to revive Amiga we need to make it cheaper. And then we figured we want to make a price-reduced version, and we planned how to do that, instead bringing that board for 800 or 700 to the market. This was a mistake, obviously, silly us. And this all took a lot of time, and I have to say, some of us also, with these projects, some people want me, but other people have a real life. And they have family or have responsibilities with friends or parents or something like that. So if they, for 7 days in a week, don't only do Amiga development, this works maybe for 1 week, but after a month they get a problem, and after a year they have lost their girlfriend. And so it became for some people in the team hard to keep pace, because if you have such a big project and you really need to fulfill every month basically some big progress to bring the Natami out, this brings people or had put people under a lot of stress.
Okay.
As mentioned, we were young and stupid and ambitious, and we overstretched the goal, right? We looked for something very high, and this did put the team under a lot of pressure. And looking back, I also created extra pressure in the team, and Thomas and me then basically disagreed. He wanted to take a break from this, and I said, well, I don't want to take a break, and if you take a break, fuck it, I continue now. No. And then I decided it's a good idea to rewrite the CPU from scratch. And
So the 68 or 80 is the CPU new, fresh. You started from scratch and not from the 68 or 50 base.
Well, it's like it's.
You got experience.
When I had my first girlfriend, I made a lot of mistakes in relationships.
Okay.
And I learned the hard way then that some things you don't do. So with the second girlfriend, I reused some of the experience. So
yeah.
The 80 is similar. So I learned from, or Jens and me, we learned from what didn't work so well with the 050.
Okay.
And we learned what went really good with the 050. And based on this, we put basically the ideas together and started a design which was multi instructions per cycle and was designed to support hyper-threading and all those buzzwords with all these modern CPUs from IBM and Intel have. And as you see, the 080 really works nice now. And at some point, Igor contacted me. Igor,
Lucky Boy. It's the keyword. Okay.
Yeah, this is on the left-hand side. The guy who looks like he comes from jail as Igor. He looks a bit angry, doesn't he?
This is his best shot. I found
It's a nice
this.
photo. I like it.
It's an ugly mugshot photo. I haven't.
Yeah,
The best one. And
you can use in a video game as the bad guy.
yeah, and the three guys with the thumbs up in front of the big IBM poster. This is
Okay.
me, Jens, and Christoph. Christoph is the guy with the glasses, and we are all IBM guys there. And the thing was, Igor was had the smart idea to build an FPGA card, and at that time, Toby had made this 68K CPU, which he did.
I read somewhere that Igor got an Amiga on his first Amiga in 2011. It's possible.
I don't know, to be honest. What I know is that Igor wanted to make a CPU accelerator with an FPGA, and this was for him a learning project. So Igor is a self-made hardware guy who did this simply for the passion of learning stuff and improving Amiga. And at that time, shortly before this, Toby made this TG68K CPU, which is this very simple 68K implementation. It's not like heavy pipelined or superscalar like a modern CPU. It's more like a 6800, like the original CPU from the end of 70s. But it's in an FPGA, and it was compilable, and so it was used for the Minimig. And Igor's idea, which was clever, was to take the same CPU and put it in an FPGA and see what happens if he replaces the CPU in an Amiga 600 with it. And this was because he only had a 600. He didn't had another Amiga at that time. And this is how this Vampire 1 card started. And he wrote me an email asking some questions. He was very ambitious. He wanted to add a cache to the CPU of Tobias, and he did this already, but he ran into problems, and he asked me about if I could give him a hint in the email how to fix them. And I more or less said, actually, I can tell you how to fix them, but you can't reach the goal you want using this CPU because this CPU is shit. It's not designed to do what you want. It's designed to be an 00 replacement and to be, it's working internally like an 00, and what you look for is something internally modern like an 040 or so, which can use two caches and can do this and that. And for this, internal structure needs to be totally different. So you need to change this and that in the CPU to get what you want to do, but maybe you actually want to throw it away and write your CPU from scratch. It's probably about the same effort for you. And by the way, actually, I have a CPU which does all this what you want.
Okay.
And then I showed him the Apollo CPU from the he knew me from the Natami, so he knew I had a CPU. And we then talked and so on, and basically we said,
He sent you a vampire, his prototype vampire to you.
yeah. And I said, this thing is nice, but it's fucking too small. Our
Okay.
our core is designed for an FPGA 4 times the size. This won't work. And he said, you can do it, can't you? And we joked around, and I said, I give it a try. And we made a dwarf, a midget version of the Apollo core. We tried. And so started the project Apollo Core Mini. And this is still what we continue on the...
It worked.
And so originally at IBM, let's put it the other way around. Sounds like I used IBM equipment, which I of course did not. But we had lots of FPGA cards, which cost like 10,000 euros, where we did the IBM development. So IBM, for example, does exactly this, what we do. They develop a CPU in VHDL. They test it in simulation. That's also how we develop the Apollo core. And then they put the CPU in an FPGA to do the first runs, because an FPGA, of course, is never as fast as an ASIC, but it's still much faster than simulation. IBM has very expensive simulation machines. They cost like $1 million. And even they are a lot slower than FPGAs in simulating the behavior. So putting the logic in an expensive FPGA, like those big Stratix ones, which are teracells, allows IBM to, for example, to boot Linux in slow motion on like a new power chip. So if they develop a new power whatever chip, they can put it into a extremely expensive FPGA card, which has maybe 4 of those $10,000 FPGAs on it, and then they can use this to emulate or simulate and power 10 chip or so, and boot with this in 10 minutes a Linux system. So it's kind of slow. It runs like 50 megahertz or so, but it works, and you can. It runs much faster than simulation. Simulation doesn't get close to a megahertz. So I booted Linux once in simulations. Took like 2 weeks or so. So forget it. And hogging a 1 million simulation machine for 2 weeks, you can't do very often. They kill you if you do it a small amount. So we use what Intel guys and IBM guys and all those big companies also do. They develop the chips in an FPGA, and then we did just the very same for the Apollo core and Nakami. And so Igor's card made absolutely sense. Using a CPU in an FPGA was clever. It was very clever. And the Apollo core ran fine in Igor's card. We had to strip a lot out. We had to kill all the other pipelines. We had to kill some other features. We had to simplify a lot of stuff. But the core ran fine. It was the fastest card ever built for an Amiga at that time.
It was like 030, 040.
The performance?
Hmm?
Oh no, I don't recall. It was, I think, 70 MIPS or so. So it was pretty good.
Oh, okay. This is the Vampire 1.
Yeah, Vampire 1. Okay. And we are now, with the latest sysinfo, we are around 150 MIPS. Mm-hmm. This is Miri, my girlfriend, and here comes Arne, my son. He's Mr. Vampire beta tester. He has played every game on a PC.
And Anna was night.
I told you. Okay, good Nacht, Digga. Schlaf gut. Schlaf gut. Good night.
Good night, guys. I bring the
Thank you. Okay.
So his idea was great with the card, but the FPGA gave us a lot of trouble to fit the Apollo core into it, but it was great fun. And after it worked, kind of, we were a little bit unhappy that we had to disable so many features. And Igor said, yeah, make a new card.
Okay.
I said, okay, great, but please put bigger FPGA on it. He said, yeah, of course I put a bigger FPGA on it. And I said, okay, but please also put video out on it. Okay, I said, okay, I put video out on it. And that's how the Vampire 2 was created. And I'm very happy with the card. I think it's a good combination of good enough FPGA, enough memory, and it has video. And it has its limitations, but it's a very usable card. And it's a lot of fun to run the Amiga as a Vampire.
Alessio, Buggy Boy.
See.
Okay, we're talking about Vampire version 2.
Right, that's the evolution there.
The dates are correct. I guessed the dates, the years.
I assume so. Time flies. to be honest. It feels like yesterday, but
We will not put this slide on an historical book about vampires
no,
for now.
You did this very nicely. Yeah, as the Vampire 1 started simple with just one memory chip, no video and so. And then the Vampire 2 with twice the memory and video out. So, and then for the 500 with IDE on it, which we then made really fast. So it's the fastest IDE controller for Amiga, in my opinion. So this was a nice development. And Igor's latest cards, the Amiga Vampire 1200 card, is even better.
Buggy Boy, Alessio. Okay.
What is nice about these CPU cards and what is clever about them is we could reuse the stuff which was in the Amiga, which you could not do in the Natami, right?
Okay.
So Igor could use or sell or, let's say it's the other way around. If you want to give someone a complete product, like a laptop or so, it has so many parts in it which needs to work before you can call it finished. And for a small team, if you're realistically, you say you need a year for that, and a year for that, a half a year for this, and another year for that. So before you can sell this stuff, you need to work 3 years, 4 years or so. This is a long time, and this can kill a team doing this in their spare time. And the nice part about Igor's couplers, we already have the CPU, get this debugged and running with the memory controller. We wrote our own memory controller for his card and had to write a few things, so there were still many months work to put into them. But these were all manageable goals. These were goals, okay, we work half a year on this, and then people can start using it. And we knew the original FPU, which we originally planned using this $10,000 FPGAs, was too big even for the V2, so we couldn't put it in. So we knew we need to redesign the FPU from scratch, but this didn't matter. People could still use the FPGA card without the FPU being in it. It was no problem, right?
Yeah.
And so we could piece by piece first give the people the CPU, get everything with the memory controller debugged, so this works, then work on the graphic stuff. 3 months later, 4 months later, or half a year, we could enable the video out, and then we could work on the FPU. So we could gradually, piece by piece, upgrade thanks to the possibility of the FPGA that you can.
Excuse me, Gunnar. The first Vampire, Wutsu, didn't have video out activated?
The first Vampire, the Vampire 1, had no video.
Okay.
It was not designed for this. It had a very small FPGA, which was too small to fit our core originally. So it was us a lot of work to cut it down. So the next step we did on the Vampire 2 was regrow the core. So put back stuff which we turned off to make it better again. So this was a lot of work, yeah. Claudio was with us from all the time. He will recall how we had problems with the extended address modes and this and that, and re-enable this, and that was a huge amount of development, a huge amount of testing. And then we tried to run Superscalar, and this also was a huge amount of testing. And
it was an incremental work.
Yes.
Okay.
The good thing about Ego was that you could develop it piece by piece, like a salami, slice by slice. You could add new features, and you still had the whole Amiga working. The Amiga was working, the keyboard was working, the hardware was working, the mouse was working, you had audio, everything was there, and we could add piece by piece new stuff. This was the opposite to the Natami, where we at one time tried to do everything in parallel, which was maybe too big for us. It's obviously
overwhelming. Too much. To
Ci sei Stefano?
Gunnar?
yeah.
Okay. It was an overwhelming task to build Natami. Building Igor's vampire Wutsu cards was more incremental on
Yes, this was much more reasonable. This was more intelligent to do as a project, because we could, if you look at the Amiga as a total and you count the pieces, you have several chips for audio, video, memory, and so on and so forth. And trying to work on all of them in the same time, like we did in the Natami, and also trying to work on the CPU is just too many things. I mean, realistically, if you look at IBM and they do a power chip, they have 2 years time, maybe 3, and they have a team of 500 guys, okay?
Yeah.
So they split the work about a real big team. That's how they do it. And then we didn't have 500 guys. We had like 3 guys. And we simply tried to do, and we were used to do small parts in a big piece, right? We were used to do small parts in a power core. We never did everything. So now trying to do everything on our own was very optimistic, and it failed for the Natami in the time frame. It was over our possibilities in manpower. And Igor allowed us to, step by step, add one feature, improve this, test another. Okay, cool, we make a new update. And so we named the cores like metal. So you get silver cores, and after we said the CPU is now perfect, we don't need to change anything here. We call them gold cores. And then this gold 9 or so, we enabled the FPU. And so piece by piece, the cores became, I would say, really good, really excellent. And we could invent new ideas.
Yeah.
And so this made it really manageable, even for a team not being 500 people. And the V4, basically, which is now the latest card, so to say, is finally doing what we wanted to do with the Natami. We now have we want to revive the Amiga, and reviving is in the one time giving the developers something which they never had, like the world's fastest CPU. But our dream was to increase the numbers, to bring people back to the Amiga, like to have the times when I saw the Amiga 1000 in those stores. Okay, it was very expensive, but I saw it and I was like, wow, I want to buy this. And to get a machine like this back for the Amiga people, recreate. And we wanted to have a better CPU than the 060. We wanted to have more memory than the Amiga 4000 had. We wanted to have more colors, and so, but still, we wanted to be an Amiga. Yeah. What I liked about the Amiga, and opposite to the PC, was what I felt clever, smart, intelligent way of how the copper controls everything. It feels to me like organic, like a living or so. So it's I really like the ideas of the original Amiga inventor team, that they control with the copper the display, and at a certain point of the screen you could change the colors or something like that. So there were cool ideas which for me made the Amiga, and I really never liked those PC graphics cards in my Amiga 4000. I had one, like a Cybervision 64, but I didn't like that it was not real part of the Amiga. The copper, you couldn't control it, you couldn't drag down the screens, you had no sprites on it. So it was, on one hand side, it had powerful features, but it wasn't integrated. Those features, like those DMA channels and everything in the Amiga, was so nicely connected. It was not connected.
It was organic.
Yeah, it was. Everything in the Amiga is interwoven with this DMA, and it all makes sense to me, right? But putting like a voodoo in with a mediator is kind of cool. It adds features, but these features are not connected to the Amiga. So we wanted to have all these features. If we add anything, it should always be like leaves on a tree. It should be naturally grown in the Amiga, as if the original Amiga 1000 inventors would have planned it already to be in the Amiga 1000. So this was our idea of how an Amiga should be. And this is what we try to do with the Vampire.
Yeah.
We have those graphic modes, which unfortunately AGA didn't have, like a chunky or high color or true color, but they're all added in a way. The copper can control them, and the copper can make a chunky screen, and the copper can show sprites on it, and so on. So it feels like it would always have been in the Amiga. And also for the audio, we have the audio channels of the, like in the original Paula, and my son, which is now in bed, and me, we added those extra channels. And with the team, we had so many. The team is great for these things. We discuss those ideas, and everybody in the team helps to test them, and everybody in the team has an idea of what is good or what he thinks makes most sense for being in an Amiga, or has some experience which he always felt didn't work so perfect in the Amiga. I mean, every project is a compromise, right? Especially projects which go to market. They have a deadline when they have to come out. They have a deadline of money. So I'm sure the original Amiga inventors had lots of cool ideas also, but there were managers don't giving them enough money or don't giving them enough time, which made sense because if you have unlimited money and unlimited time, your product never comes out and the company goes bankrupt, right?
Yeah.
So they of course had limitations, and they needed to do compromises. I'm sure they would have wanted to add all these features, but they couldn't do it in the time for bringing the A4000 out to market. Or they might have wanted to add more audio channels, but they couldn't fill it in the timeline or in the budget. And this is also what every company has. We have it at IBM with every project. The engineers have 100 ideas, and then the management cuts it down to 90, and to fulfill the deadline, they cut another down to 80, and then the product comes out, and all the engineers are unhappy because they couldn't really do what they wanted. But it makes sense, because if they would have reached their goals, the chip wouldn't have come out in 2 years, but in 5 years, and then it wouldn't have been competitive anymore on the market, because Intel would have made all the money and IBM would have lost all the contracts. So in the big picture, all this makes sense. We have the luck now that we have no project management behind us.
And it's platform, so you don't have a pressure to be the next PlayStation 4 or the PlayStation 5.
Right. So we can have the luxury. We can infinitely often update the FPGA, so there's no limit. It's not like you write it 3 times and then it's gone. You can write 100,000 times. So we can try out new things. We can add more ideas. We can discuss how about we add 4 audio channels to 16-bit, and then we say, oh, that's pretty cool. Why don't we make it 8 channels? And then we added 8 channels, and then we said, oh, 16 channels would be even cooler, right? And now we have 16 channels with 16-bit. And then we said, well, it would be nice if each channel could be um, not only left or right, but you could play left and right in parallel from one channel. So it's like 16 stereo channels, like 32 channels, so to say. So we we can grow those ideas.
And it remains compatible, hardware compatible with the original Paula.
Yes,
It's right.
It's absolutely Paula's design. It's the same state machine. It's
Incremental.
Yeah, it's incremental. I mean, Paula was good, but Paula had a few compromises. So at that point of time, for example, playing a wave, a PCM audio file of 128 kilobytes, which is the limit of Paula, which you can play with one command, looked huge. I mean, it was the time of the Commodore 64, right? The whole computer had 64 kilobytes of memory. And here you had an audio chip, which got 4 channels, and each channel could in parallel play a wave of 128 kilobytes. This is unbelievable at that point of time if you think the computer at that time had only 64 kilobytes. If we now look at this, you say, maybe it would be cool if I could play a bigger wave, because my, I don't know, MP3 file, when I turn it into a wave, is much bigger. So if I could just play it with one command, it would make coding for me easier. We added these features. So, and it looks and it feels like they've always been there. So you can now play basically infinite wave files with one command. Or we added a more fine-grained volume control, but all in a way that I think it's very clean, and it feels like Paula, and it is still Paula, but it has some upgrades.
It's an idea of continuity.
Yes.
Like the original Commodore set.
And it fully is in it's the same machine, it's the same register space, it behaves the same, it does the same DMA, it can be fully controlled by the copper. So all the tricks, and what to me was Amiga, right? That the copper could change the screens or copper bars or the sprite, you can still do, even with the new sprites and the new Paula and the new graphic features. So I don't know how to describe it, but it's basically like the original Amiga inventor team just would have had more time and money, and they could have added more of their ideas and dreams.
Yeah. That's cool. Okay, we pass to the next slide. Okay. Oh, these are some photos.
Yeah.
The first one is with Yuki, Ramzan, and other people. You were in Italy, or you were in?
Yeah, this is North Italy. We visited her, and I mean, this is a nice thing. I really love about the Amiga scene. There are more crazy people like me, which fell in love with the Amiga and never stopped loving it. And you can meet them, and these are great people, and you share. They understand you why we do this, and they sorry, and they yeah, they are nice to you, and you can talk about stuff, or some help you develop some test cases or so. And yeah, Ramjam also very nice, and we visited her and her husband. And
I don't know if you know, but Ramzan puts online an old assembly course in Italian, and that assembly course is maybe the most influential coders reference in for Italian people.
yeah, I've I once read it. I didn't understand the Italian. I could read the assembly lines, but yeah,
It's a very, very good course. It's big and very easy to understand.
this is good stuff. I mean, um, to me, coding and assembly was really what made, when I was young, a lot of fun. Maybe I'm too old for this now, but I still code assembly. And
Yeah.
with my son the other day, we wrote a little game for Amiga in assembly. And I tried to teach him assembly. So what else?
Yeah. No.
Then,
How the Bosch started with this course?
I started with the Run Jam course. That's how I started. Just because I googled M68 assembler on Google, and I found out that there was this great course in TXT format, and I started reading a chapter every week. At first, for me, was very hard because I am younger. I started with C, and it was really different. And for me, it's different because I didn't care what was under the C language. I didn't know what a program counter is or what a status register is, because these things are not taught in the school, and in every modern programming book there's no mention about the architecture, the CPU architecture. I just care how to write some code that can be understood by a compiler. So my first chapter was like a nightmare, because I really didn't understand what's an operand. Why do I need to know such a huge list of commands like move and link? And if I want to branch, I called that an if, a condition. I learned that this is a branch, and you can branch in a lot of time. And the same things with the iteration. I had to learn how to iterate in assembler, and it was a nightmare, a very nightmare for me. I was more a Java guy. It's really easy. I just copy and paste some random stuff on Stack Overflow, and it works. There's only one way to do this, and if I do something wrong, I have an exception is thrown. It's very easy to understand what's wrong. With assembler, it's different. I have my Amiga stuck. I don't know why. I read again my old code. I don't know where the problem is. So I started to see how to debug with an emulator, how to do a step-by-step inspection inside the memory. That's how I started. But for me, it's really hard because it's so far away from my conception of programming. But RamJam helped me a lot. I also read the Total Assembler. It's another great book. If you have some literature to suggest, please do it.
well, yeah, for me it's the other way around. I started with the Commodore 64, and so Java or something didn't exist at that time, of course. And when I started with 14 with the Amiga 1000, I started very quickly because of my friends with assembly, and they gave me some floppies with some demo code from Cortex or so, or Reflector at that point of time, and I had a manual of the Motorola 68K, and they said, okay, look at this. try to understand it, and in 2 weeks, come back and we make a demo. We need one for our new crack. And I said, okay. and that's how I started. So my approach that
We start with the 68K manual from Motorola, maybe, and the hardware reference manual from Commodore Amiga.
yeah, the white one with the
This is your main reading.
so yeah. I mean, I looked at the code of these intros and tried to understand them and changed first only the scroll text in them. And, okay, it works. And piece by piece, I learned assembly. And my approach always is do little by little, small changes. And when it crashes, your last 3 lines you change are wrong. So I really never needed to use a debugger because I do iterative things. I do small things, I test them, works. Another small thing, test them, works. And because I always test every small thing, I always know I made a bug in the last 20 lines I changed. So I didn't use a debugger since 30 years on Amiga because I only changed small stuff. That's how I learned it. But yeah, everyone has a different history and different working style.
One thing, because RamJam course is so great, is because it's full of source code and examples, and you can open it, you can tweak it, you can do another project based on the simple one that you find in the course. And for me, that's how I started in Amiga programming, but it was 2 or 3 years ago, so I'm a young programmer now. Then I realized that there is a guy named Bebo, you know him, and he made a GC compiler. And for me, it's more like, it's better for me because it's my, it's nearer, it's a high-level language. I know it's cumbersome in some way. Probably I don't even inspect the code that GCC generates, and I know probably assembler could give me more speed. That's probably the way to go. But I speed up a lot the development process with Bebos. That's how I program today. But the crucial parts, the routines that gets called over and over again, process, and I will still use assembler for this. That's how I do stuff today. Very little stuff because I'm not an experienced programmer. I am not a developer. I work in a telco company that I have nothing to do with this stuff. I made some simple demos in the last years. I having fun, but for me, the real fun is programming the chipset, writing the copper list, and writing, loading the registers for the. That's for me the Amiga is the chipset, not only the processor.
Yeah, the combination is yeah, you're right. I mean, it's absolutely clever to use the right tools for the right job. It doesn't make sense to write a text editor in C, right? The text editor mostly waits for the user input, and using assembly to make it faster doesn't make sense. Even C is maybe the wrong language. Maybe using Modular or Oberon, which is more Pascal-like and doesn't crash so easily as C, would be a better choice even for writing a tool like that. At the end, my experience is the algorithm should be first optimized. So, I mean, it doesn't make sense to highly tune a bubble sort. If what you really need to do is maybe a merge sort or a quick sort. So that's maybe the problem that many assembler coders do. They lose themselves in tuning something unimportant, right? I mean, for GCC, what you say, you use Debo's GCC version. GCC is very old. GCC used to have reasonable 68K support. The 2.9 line was not bad in code generation. And then Motorola adopted 68K, of course. And the GCC was partly rewritten, the 3 line, the 4 line, now the 6 line, and the newer one. And there, it's a monarch. It's a big monster which the GCC developers have problems to overlook. And the backend for the 68K is neglected. And the code generation is Meteor. I mean, that's the case, right? That's simply the fact. The compiler creates working code, that's great. It can compile modern C-style codes, it's also great. But it has no clue how the 68K works, and the code it generates is, it's okay, right? But I mean, our problem is we don't have 5 gigahertz, we don't have 6 gigahertz cores. So for us, it really makes a difference if a problem is solved in 5 instructions or 15. So bad code generation by a compiler can really hurt us because we don't have much power. If you have 5 gigahertz,
Okay.
you can solve everything. You simply throw billions of instructions per seconds against it, right? And that's what real Intel chips have. And frankly, the ZGC code for Intel is 10 times better than for 68K, because the Intel guys, they have full-time employees which do nothing else than improving GCC. So does IBM. IBM has a full staff, a floor of guys working on GCC for power. So the full-time C developers which do nothing else than patching GCC and adding improvements to it. So there's nothing like that for 68K since 20 years. So the code generation obviously can't be good.
So the old lattice or SAS is will generate a better code than GCC.
It depends very much on the problem. And for some problems, I mean, GCC, the 2.9, let's say it in other words, if you have a CPU, it's not easy to say what is fast on a CPU or how fast is a CPU, because a CPU supports many different instructions. Just giving an example, the 68K might support, just throwing a number, support 70 instructions. And each instruction can be byte, word, long word. So now you have 210. And if you on those add the different addressing modes, let's say it's 10 address modes, now you have 2,000 variations of instructions the CPU can support. Okay, so how do you want to solve the problem? You would write something in C, and the C compiler could throw a variation of different instructions resulting in the same result. You know, you could sometimes to duplicate a value, to make it twice, you could add it 2 times together. Or you could multiply it with 2. Or you could shift it by 1 bit. Each of these different things will result in the same result. And this is just one example. So every problem you solve has different ways. So there's many roads to Rome, so to say, right?
Okay.
And so a compiler needs to make a decision which is the best one now. And with all those different address modes, he has, for the 68K, so many choices. And some instructions are longer, need more bytes. some instructions might take longer, need more cycles. And if you have something like a superscalar processor, like the 060 or 080, which can execute 2 or maybe 3 or sometimes even 4 instructions in one cycle, it makes it even more complicated to pick the best mix of instructions. Because if you have instructions which are depending, then they can't be executed in parallel. So they will be maybe slower on such a CPU than other instructions which are independent. So a good compiler will take all these into consideration, and it will try to make again something like a perfect compromise, to use a combination of instructions which aren't too big, which run reasonably fast, and he will try to shuffle them around, let's say, well distributed about several units in the CPU. So the CPU can use multiple instructions per cycle on them, which is only possible if the mix is reasonable. And if you only throw division instructions or so, and you have only one divide unit, you cannot use parallelism in the CPU. And so as more the compiler knows about how a CPU works, as better it can put all this into account. And the 68K line has a number of, let's say, specialities which some CPUs not have. So the 68K line has address registers and data registers, and they are different because you have address calculation units for the 68K, which are especially designed to manipulate those address registers. So to make the perfect code mix, a good programmer would know this, and he would throw instructions running independent. And today, the GCC is clueless about this for the 68K. So the code generation for 060 and 080 and even 040, it doesn't know enough about those CPUs. And if you have plenty of time and a lot of C skill, you could add all this to GCC, and this would improve the code generation a lot.
Okay.
Did you expect the executables that came out, the major C compilers, for example, GCC and VB? Did you ever test them and see which is the best, or how far they are from perfection?
Perfection is not the word, I think.
Bebo is perfect because the code works. It works. In a vampire flies.
Well, let's look at this. I mean, I like AROS. Yes, I think AROS is the only option we have in the Amiga world. My dream is revive Amiga. And I think to revive Amiga, you need 3 things. You need the 68K CPU. Okay, this we have. Check mark. You need the chipset. Another check mark. And of course, you need the OS, the Amiga OS. And the Amiga OS, in my opinion, got lost in legal void. I don't believe the Hyperion owns anything. And I don't think Cloanto really owns much.
You can change the slide, Alessio.
My personal belief is that
There's the Cloanto guy here.
yeah, Mike. My belief, honest belief, is that Amiga went bankrupt and they were a smart company. They had their because of tax reasons on the Philippines or whatever. So it was all complicated, constructed, and then they were bought by another one. And we all know at ESCOM and Gateway, and all they, like those bubbles, these companies died. And I believe, or I witnessed at that time, I also worked for ESCOM during the time for a very short period on a project, that I think these companies originally, like Capcom wanted to continue the Amiga and revive it, but they were mostly interested also in the stock of the 1200s lying around in some warehouses. And I don't think that all these companies actually valued Amiga as OS as having a future. So I believe that in these contracts, they forgot about it. And no one really knows who owns it still, if Acer still owns it or whoever. And I think Hyperion and Cluanto know that they can make money because no one really owns Amiga OS anymore. So the guys do basically what I did on the schoolyard. They're selling wares. I didn't sell wares, but I swapped them, and they sell it now. This is my personal view on the subject. I think the real ownership and legality transfer never really happened because everyone only wanted the plans of the Walker and hoped for a chipset or hoped for a warehouse full of Amiga 1200s to resell them quickly. And so
that's a possibility.
I had, like you see on the picture on the right hand side,
The other guy is a big one, a big person.
This is Timothy from Italia.
Dave Haney.
Dave Haney is an engineer. So with Dave Haney, I'm good friends, right? We both have the same heart. We have the same spirit, and we can fall in love for engineer ideas. Yeah, we say Amiga was a great idea. This was wonderful, and it's a pity they ran out of time or couldn't do that. So we think the same line here. It's easy to like what Dave does, and for Dave it's very easy to laugh at what we do. And when we met, he really said he loves the Natami idea. He likes the vampires very much, and he got one on the Amiga 34 meeting, and he really likes it. He said, and
he wrote an article about this vampire before.
He was really impressed with what we did. He really was impressed with the CPU. And he said if Commodore would have had the 080 CPU, they would have ruled the world.
Oh, yeah.
And it's true. I mean, at that time, it would have been a killer. And so it's easy to get very good along with Dave because he has the same spirit, and he would have loved if Amiga wouldn't have died. It's the same as us. It's very difficult for me to get along with Hyperion.
Yeah, we know. But this guy is not working for Hyperion or Timothy. He is in legal cause with Hermans, I think.
Yeah. What shall I say? If the CIOs of Hyperion sue each other,
yeah, it seems so.
For everyone to leave the sinking boat, I think. Yeah, I mean, well, looking back in history, my personal view on the whole story is that there was a company in the US which got some naming rights, and there was Bill Buck from the Morpheus guys who wanted to, who was together with the development team of Amiga hardware. So Bill Buck was very close to the Phase 5 guys, with the Cyberstorm and the Cybervision, which without a doubt were at their time the most advanced cards for Amiga ever.
Yeah.
So they did awesome stuff, right? And they not only did great hardware, they did also stuff like the drivers, Cybervision, and so they did real complex software stuff also. And I know them also from IBM times, funnily, because the Phase 5 guys, later called B-Plan, even developed a PowerPC machine for IBM. So,
yeah.
yeah. IBM didn't have the manpower to do every project they wanted to do, so they outsourced one development project to them. Very funny, huh?
Genesis, it was no Bplan or Genesis is the same company, or was the same company.
Yeah, yeah. I mean, B-Plan is, to me, the Phase 5 guys, and Genesee is Bill Buck and Raquel, and they got together a number of very well-known Amiga developers from the software side and hardware developers. And Bill Buck is a very good manager guy, I would say. He made very good contacts to Motorola Freescale, and he made some nice deals getting G4 PowerPC chips from Freescale. And so he arranged a lot of things which were very good, and based on this, Pegasus and Morpheus development started, and this was their vision to revive Amiga, and I think it was a great idea because they had a lot of experience with PowerPC, the B-Plan guys, and they had good development skills and software development. So this was very clever, and looked to me like a good plan. And I also tried to support them how far I could, at least.
I remember the box what with the Caipirinha chip inside. This was from Phase 5 times, but do you remember that?
No,
Okay.
but yeah. Well, Hyperion, to me, if I recall the story right, then B-Plan, the Morphos guys, got the deal to develop OS4, so to say, from Amiga Inc. And more or less, the Amiga guy holding the names, the rights. This is my memory to this is that he bailed out of the story of this deal, and found another partner giving him better terms, where he believed to make more money with, and these were the freedoms from Hyperion, which had a good name importing PC games, right? Like Quake or Doom kind of stuff, and so they had a name importing existing games to the Amiga, and having experience with PowerPC also, and then they made a deal with him to do basically what he already had to deal with the Morphos people. So this is how I recall the story. So
I heard something like this somewhere. So you recall this story, right?
yeah, and we all know what happened, right? Hyperion made a very clever contract with this guy that they have to deliver to a certain point of time their port. And if they don't deliver it by that point of time, I don't know, they get less money or something. And he has also to pay. And if he doesn't pay by this point of time, then they own the right on the outcome. So the strongest part of their work was this contract they made. And I'm not such a contract guy. I hate people doing this, right? It feels like it doesn't feel right to me to make such contracts. I couldn't look in the mirror in the morning and shave by doing this. But this Ben guy is a lawyer, so he doesn't have moral problems like me here. And I think this is the story. Like, to me, this is thieves. This is used car salesman tactics. This is a trickster that does sells to an old lady something she doesn't need, or a trick contract, Nigerian scam. I don't know how to call it. I'm too much engineer, and I'm frankly too honest, and I say too much what I think.
Yeah.
But I don't like this. How Hyperion.
If you wanted to publish this video on YouTube, it's better to avoid too many.
No, but do what you want. I mean, so honestly, I told Timothy in the face what I think about this. I mean, Timothy's a nice guy. Timothy's not an engineer, so he doesn't have a clue how a CPU ticks internally. He doesn't understand, like a demo coder would understand how the Amiga chipset works, but he loves Amiga. He is an Amiga guy, right? He is a fan of Amiga like many of us are, and he is in this for reviving Amiga, and so by heart he is really a nice guy, right? I just don't like the legal practices which are involved in this company. I think Hyperion did a not bad job, a good job in porting some of the OS to PowerPC, so this is great. They didn't have the possibility to develop an own CPU, so they needed to go the PowerPC route, which is absolutely understandable. If you can't develop your 68K, and you want to continue, you want to revive, you look for an alternative. You could look for Coldfire, you could look for PowerPC, you could look for an Intel. So what they did was very reasonable. They looked for an alternative to revive Amiga. To me, having written many 10,000 lines of PowerPC assembly, PowerPC doesn't have the charm and the spirit of the 68K. So it's really painful. It's like toothache compared to coding on the 68K. But if you have no other choice, I understand this move completely. And of course, they don't have the possibility to redevelop the Amiga chips, so they needed to use a PC graphics card. So also this move, I understand. In the end, what comes out is not what I would have wanted in an Amiga. Yeah? I hated that the PC graphics card, which I had in my Amiga 4000, wasn't integrated in the chipset. So this I disliked on my Cybervision. But I understand why they had only this choice, because they couldn't build the copper, they couldn't integrate it. So they tried with the options they had to do as much as they could to revive Amiga. I fully understand this, and the spirit is great. I love the spirit. And this is also what many people love about OS4. It's one way to continue the dream with the options that people have. So I fully understand why so many people like OS4. But I don't like some of the battles behind the curtain, you know.
Okay. Okay. we understood. Okay.
And I love ours for not being involved in all those legal battles. And
yeah.
if we want to revive Amiga, it's the legal thingies which killed Amiga many times, right? It's the legal side which killed all this. It's not the engineers and not the dreams and not the spirit which killed Amiga. It's all those legal problems which killed Amiga. And when I met with Hyperion on this Cluanto, it was at the Gamescom, it was in August, 13 months ago, right? So 1 year, 1 month ago. And at that time I spoke to them and asked them, how about making a deal? We have those nice cards and we want to sell them, and wouldn't it be nice if we could legally, I don't know, make a sign here and we give you 1 million pesos and we ship them those boards. And
You talked to Mike or to Timothy?
both,
Both.
both at the same time, so to say. And the answer was more or less the same. Neither of them knows if they can make us a deal yet. They still have their internal legal battle, which will soon be settled, and then they can make deals. And this is now 30 months ago, and nothing settled. And I'm happy we saw the writing on the wall that, yeah, I'm sure they want to settle, or maybe they don't want to settle, because maybe the settlement will show that none of them has any rights. I mean, if the court is any good, they may find this out. I don't know. So I think the best for us is not to be dependent on. I mean, Hyperion was how many times nearly bankrupt? I forgot to count. Do you know?
Who saves Hyperion every time?
I mean, Tim saved it once, so this is why he was CL. Tim, to my knowledge, he was beta tester, and he pulled his purse and put money on the table to save Hyperion from going bankrupt, and so he became from the beta tester and the team to become a CEO. And yeah, I mean, he's with love to the Amiga. So he put money on the table because he wanted to save Amiga. So he's a real fan, or he's an Amiga fan like us, like everyone here, right?
Okay.
But yeah, I think Hyperion a few times nearly died, and now those OS 3.1.4 sales keep them alive and over the water. And if they would not make money on selling OS 3, they I think they would be dead by now a long time.
It's
Yeah.
interesting.
But this is, for me, is
You think that the sales of 3.1 and 4 could be enough to take a bankrupt company alive?
yeah, they have no employees, they have no company building. So this is not a real company. I know they have two CEOs and that's everything. So the original developers of Hyperion, the Freedens, are not with them anymore since years. So the company is only run by this lawyer guy. They have no developers. But yeah, but this is not the future. The future, to me, is something which allows us to revive Amiga. And I think Aros is the right thing here. Aros is...
Let's go, Buggy Boy.
Yeah, nice. I think Aros has the right spirit. Yeah, this was also made by Amiga fans, which wanted to replace the OS, which no one knows who owns it, with something free. Like Linux is a free version of System 5 Unix, right? So this is the very same idea. You just know what you want to write. Yeah, you have like a plan. It should look at the end like, I don't know, this intro from Cortex, and you start coding that it looks the same. And that's what they did with Amiga OS, and they did well. Amiga OS Abbas really re-implements like 95% of Amiga OS. So it's great. They added also new stuff which was never in Amiga OS, like USB drivers and stuff like that. And so, well, they added stuff which was third party in Amiga OS, but originally not included in Amiga OS. Yeah. So it's very, from the spirit, it's great. At some point, they had the problem that they wanted faster machines. They didn't want to stay on the Amiga 1200, and they wanted to use a PC because this was the only fast machine people could buy normally or have at home, which is obviously a sensible decision.
It was the right decision at the time, maybe.
Yeah, I mean, if you have your 1200 with a 14 megahertz CPU and also a laptop with a gigahertz CPU, you think, it would be cool if I could use this CPU. I have much more horsepower. I fully understand this decision, but this made them, well, Amiga OS in the first place was very clean in going directly to the Amiga hardware, which made it very easy to understand, or was to me also part of the charm, right? If you have read the Amiga hardware reference manual, it very cleanly, very clear. Every part of the hardware is clearly explained, from audio, bit planes, copper, splitter, sprites, floppy disk. Every part interrupts everything is clearly explained, understandable. You read it, and after this, you have all 1,000 registers of the Amiga in your brain, and you know everything. And everything is crystal clear. And every program you write for the Amiga knows this, or can use this, right? You have, in Amiga OS, you have the operating system calls you can use to play a wave, a sound file. So you could do the operating system way. But if you read the book, you know how the operating system does this, and you know which registers it will peek and poke to get this done. And like you did on the Commodore 64, if you started there, you knew those pokes, and you know if you do this poke, the screen will turn red, or the screen will turn
I
black.
remember some listing, some source code from Commodore 64. Yes, all pick and poke.
Yeah. So you knew you knew if you knew the address of the register and understood how it worked, you could with 5 pokes also play a wave on Amiga. So you need just 5 move instructions to set the right values, and the wave would just play. And every Amiga program could use it. And this was always the same on every Amiga, from the 1000 to the 4000. So this is a nice thingy on the Amiga which never changed, and which made Amiga coding so straightforward. Every intro, every demo, if it wants to check if the mouse button is pressed, it tests for bit 6 in the BFE 000 register, right? every demo, every intro on Amiga does this with one bit test instruction. And this is a complete opposite to a PC. And in PC, you never know nothing what is under there. So every mouse could behave different, and every audio card could behave different. And you never could like this code just to register and use it. And you always have to ask the stupid driver, and the stupid driver will then want from you that you give it a pointer to a data structure where it then will fill in values for you, and then you can read it out and see, okay, the user didn't press a button, okay, thank you. But to fill out the structure, maybe 10,000 instructions were executed because you needed to call a layer and the driver and blah, 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 blah. And your memory protection, so it needs to go to a system call which copies a structure from A to B, and so what is very direct and very simple and very easy to understand on the Amiga, and which made stupid people like me able to write assembly because it was so clearly explained in the hardware reference menu, becomes a Hercules task on a PC because there is so much variation.
Yeah.
And what the Arrows guys did, they had to add this variation to the Amiga OS to make Arrows run on the PC. So they needed to add this, what I never liked on Linux, all these layers, which made the programmer becoming further away from the hardware. And at the end, not understanding anymore what the hardware does, needing to understand, not knowing what the layers in between actually do, which then comes to this Java problem that you cast a new instruction and you don't have a clue what's actually going on. And is this new instruction 1 cycle or a million cycle? What does it do? Right? You lose the overview what's going on, and software becomes slow and no one knows why. And similar happens also to errors, right? They needed to add layers. Absolutely understandable that they needed to do this because they suddenly didn't have one clear hardware anymore. The Amiga, they had different PC cards. They wanted to run on a Mac maybe too. So variations. So they needed to add layers and abstractions. And for stupid guys like me, when I look at the hours code and I think, something's not right here. Let me look at the function, and I think I find it, and I fix it, believe to fix it, and I compile it, nothing changed. Oh, this was in the driver for that IDE chip, not for my IDE chip. I just fixed the bug on the other hardware. Oh, I need to look at my driver now. So with all these layers of abstractions and these funky object orientation programming and overlaying of stuff, stupid people like me get easily lost. And while I have no problem disassembling kickstarts and changing something in hours becomes much more fuzzy to me. And this is what I not like so much on what happened to ours. I
So-
fully understand that's
So
what
you think to strip down all the abstraction from the PC arrows?
simply a self-defense because it's too complex for me to understand. And I really love the direct and clean way how Amiga OS was done and how it gave so much freedom and flexibility to the coders. You know, I could understand how it worked. I could overlay functions. I could replace a pointer to some function, and I could monitor when something is used, like Snoop does. You know, Snoop replaces all those pointers to the functions and monitors how you use the OS. So this is very easy with Amiga OS because all is crystal clear to you if you want to read the books. And I would love to get ours to be like 100% twin brother of original Amiga OS to do exactly on each function call what the original Amiga OS does, to be replaceable. So I want to take intuition from Amiga OS and drop it into AROS and take out intuition of AROS and throw it into the trash can, and it should still work. So I want each piece be 100% compatible and exchangeable. And only when this happens, I can be sure that every old software once written for Amiga OS will 100% run also on AROS. So this is the way to get there, I believe.
Big task.
Developing a AGA chip, this is also a big task, or developing a memory controller. So all of these tasks are big. I still have some here. We'll see how much is left when we are done with this. But I mean, you have to have some hobby or you have to have some goals in life. My goal is to revive Amiga, and I think this is the spirit of all of us on the team. Everyone in our Apollo team is all great guys, and they all love Amiga. And I mean, we are happy that we reached so many goals, like having these nice vampire cards. But I'm not satisfied yet until I think we have everything together to revive Amiga. And for me, reviving Amiga means I have the blueprints of the chipset, I have the blueprints of the CPU, and I have the source code of the OS. And if Commodore next generation company, Sony, comes to me and says, "Oh, you have everything to build an Amiga." I said, "Yes, I have everything to build an Amiga." And say, "Oh, cool, I have a fab, I can build 1,000,000 of them." I said, yeah, let's do it. So I want to be ready for this and want to prepare everything that together with some crazy millionaire or whoever, we could really make Amigas show up in every media market or sell them at every single store. So this is my dream, and I want to prepare for this.
Wow.
That's crazy, huh?
It's fantastic. This the thing.
I have a question for Gunnar. It's Apollo S related. When you decided to fork Eros and make your own version, did you consider forking a very version of Eros? I'm asking this because I assume that if you fork a first release of Eros, maybe you have less abstraction layer, and that's your problem, if I got it right. Your problem is the hardware abstraction layer. Maybe in the earlier version of Eros, there is just a little bit of HAI.
I wasn't smart enough to come to this idea. We started with the latest Eros version. And I have to say, I'm very happy with it because it actually works. Yeah. By all the negativity which sounded in my words, don't get me wrong. AROS, as it works. Okay, it works. This is a big plus. This is like with Igor's vampire card putting in an Amiga 500. The 500 works. Yeah, and we could piece by piece add a faster CPU, fast video out, and a fast FPU in this FPGA card. And with the arrows, we have the same now. It simply works. I'm a little bit unhappy about performance in some areas. I'm a little bit unhappy is that maybe of all these, I don't know the number of my head, let's say 1,000 operating system call functions Amiga OS has, they only implemented 950 or so 50 are missing. Some rare draw, some filled circle function or so is simply missing in errors. So if you have an old program doing this, nothing happens. No. But it's not a problem because these functions are not required to run the operating system. These are nice to have, and on a rainy weekend I could sit down, or you or anyone, and could write this function and add this. And then the OS is better. It's more complete. And 50 functions in the future, it's 100% complete. And it has, of course, other stuff. It has like USB, it has TCP, IP, Internet, and so it's drivers for features Amiga OS never came with. So if you look at this then, it has a lot more functions than Amiga OS ever had. And yeah, there are a few things. I'm very performance junkie. I'm always, when I wrote in assembly, tried to write the fastest line drawing routine or the fastest show as many sprites as possible intro effect. So this was always the geek thingy, which demo coders wanted to show more voxels than Red Hat could or Cortex could. So you always have competition in performance. And when I worked at IBM, I always was kind of speed hunting in those make the fastest computer projects and these things. So I was always look at AROS also in this regard, and I think the IDE stack, we tweak a little bit here, a little bit there, it should be 20% faster, or TCP IP, we are not as fast as it could be twice as fast as we rewrite this. But this is high level whining. The good thing is it works, right? Better to have a car that runs slowly than no car at all. So it's a great basis which people with motivation and some skill, and it's open source, so everyone can join and help, could use to make it really better. And I believe nothing is preventing people now. And when to me, it's I find it a little bit complicated and confusing with these abstraction layers. To be honest, this is one of the reasons I want to remove them. Not only because it's un-Amiga and because it's making them slower. Yeah, I find it also confusing, especially as I'm only interested in Amiga. I care shit about laptops and Mac, and I don't want to run it on those. And I don't want to run it on an Intel. So for me, I want to directly, hang on, let me pull out the Bible. Every day I'm reading it, of course. Yeah, I'm writing something in the Blitter today. So I want to go to the hardware directly because I learned these registers when I was 14 and I still remember them, and that's everything I still remember. I don't need other hardware there. I don't want other hardware. I want to go directly to the bit of the mouse register, and when I have now a USB mouse on the Vampire, in hardware, we speak the USB protocol. We wrote this ourselves. But what comes out here ends in the registers of the Amiga chipset. So it looks like there's no USB mouse to the Amiga, and it looks to all the programs like it's a normal Amiga register. So the abstraction to me doesn't need to be in the driver. The abstraction is in the hardware. The abstraction is in the registers that are defined in the hardware reference menu. So this is our way how we do the abstraction. We keep the registers of the Amiga behaving as they should be. Even if there is a different hardware now connected, the Amiga registers show the correct content. So our abstraction is not in software but in hardware, and therefore we don't need no abstraction layers in the OS. And I believe it will make the OS much simpler if you remove them. And it will be like the original Amiga OS. And I think this is the right way to revive Amiga OS. This will be needed to revive Amiga.
Wow. Okay, Gunnar, have you other 5 minutes for some fast question?
Sure.
Ok. Alessio, puoi aprire il sito? Riesci a condividere? Il forum per le domande?
Oh yeah, one moment. Le domande.
Fai te?
International English only. Questions for Gunnar.
Okay. I don't read, so I can go. It's not readable for me, but the first one from Farox was okay.
He already answered that. I think.
Yeah,
Go for slides.
Then there, your question? Oh,
There is my question. It's about poll on Facebook by Jesus. I don't know if.
Manuel Jesus from.
So this guy Jesus, it's a Apollo team member, I think, made a poll some days ago about how should they improve or proceed in the Core 3 process development. Mm-hmm. So he gave, I think, three different options. I don't know the outcome of this poll, but the real question is, do the Apollo team honor this poll, or is just something that came out of Jesus' mind?
Jesus Christ.
Well, Jesus is Manuel, and he's part of the team since the very beginning, and he designed the logo of the vampire and other things. And to say yes, I mean, we always try to listen to, even if I don't sound like that, I care about people.
That's not true.
I think everything we do is motivated by trying to make the Amiga better. Yeah. So when we look at whatever we do, we look at how do people use the Amiga, and where do people have problems, right? Performance is one limitation. So the CPU tries to fix this. And we always wanted to be able to watch videos or to play more colorful games with Amiga. So the SIMD instructions that we added to the CPU was aimed to help here, to enable playback of videos, to enable that games run quicker. And you see this in our Diablo port, like it runs much faster than on a gigahertz PowerPC on the Vampire. because it uses those AMMX instructions and plays with a really great frame rate from 80 or 90 frames per second peak. So everything we kind of do, we do not only because it's geeky and because it's cool or a lot of work. We always think we solve something, or we try to improve the world, or for Amiga use or something, right? So in my belief, everything we do is motivated by making the Amiga better for the people. So we believe we are the good guys. And we believe we solve other people's problems with the stuff we do. And when we add more audio channels, we believe this will make music, developing music with the Amiga easier. And we believe or hope this will give in the future more music programs and more musicians doing cool stuff to Amiga people. So we always have a vision that this will enable the Amiga to be easier to program, or which will make more people create more games and so. So we always try to look at these things in the Amiga, or where we believe we could fix or improve stuff, and all our goal always is to do this. We have a lot of motivation there. If you look at AGA, we started developing AGA as part of the Vampire 2. So when the Vampire 2 was plugged into my Amiga 500, I rewrote AGA there from scratch. So so this was for me a development vehicle to develop AGA, and we need, of course, the AGA as part of the Saga, the Super AGA chipset, to be able to play our games in the V4. And right now, we are very focused on polishing AGA fully and getting it better and better. Like I said, today was testing and debugging some games with a Blitter, or Saga Blitter implementation, and trying to find out why one game looks different in it than on the original. And so right now the V4 is good, I would say, but I want to make it better. And our goal is that very many, or nearly all, like from 199 games, should work like on the original. And as the Vampire is much faster and has a number of other enhancements, this also gives a number of challenges for old programs. So some old programs rely on being slow to work correctly because of some oversights or something not correctly checked in for programming environment. So our goal is here to find solutions so that if an old program only works well if CPU is slow, we have this turbo mode which makes the CPU become slow to enable these programs. And if a program starts a blitz job, a typical problem is you start a blitz job before the second job, before the first one is finished, and now you interrupt the first one in the middle, and this can lead to unexpected behavior, even crashes, because the blitter could, like a machine gun, go through your memory and override everything. And also here we look for solutions, like we have a special unit which monitors if the blitter is finished, and if the blitter is not finished, it prevents the CPU from starting a new job or preventing this hazard to happen that the blitter can go ever. So I think we always try to make it better, to make the Amiga more child-safe, less crashy, to fix problems, to make it easier to code. The other day I explained in our channel how we changed the caches so that the memory is coherent, that you don't need function calls after you did DMA, So to make programming easier, and this is to prevent situations where you could crash the Amiga. And we do this always with thinking, how could the hardware be more better to use or more robust or doesn't crash? How could we make the hardware smarter? And if you look at goal 3, this is basically the idea to put this all back into the V2 or V500 for the Amiga 500. And to be honest, all those ideas we put into the Super AGA chip come for a price. Everything costs a little space in the FPGA. And we have now too much pieces to put into the V500 FPGA. And we are aware of this. So, and the V4 has a different FPGA model. And it's not only different size, but it's also internally like a little bit different architecture. So just taking this stuff and putting it back is not, it's not a task you do in a day. It needs, I don't say it needs like translating something from French to Italian, but it's work. And it's a lot of effort, and it could take a few weeks or months. So this is why I can't just make a compile quickly for the V500, because it's a real effort, right? Don't say I want to translate the Bible, but it's a lot of work. And I think I know there are options or possibilities to shrink the size of the Super EGA but this is a lot of effort, and I don't at the moment today have the time for this, because right now Super AGA is like 90% ready, and I first need to make it 100% ready before we can think about translating it to the V500. And I think what Jesus tried to say was exactly this. He tried to communicate this to the users, to say, yes, we have developed Super AGA. It's good and running well. We still have plans to continue to improve this. Our plans will certainly take the whole year 2020 to polish AGA even more. So in the year 2021, we will then say, okay, Super AGA is perfect. And then we could look back into porting it to the V500, but to be honest, it's grown nice and well, and this is like putting a Ferrari engine into a Fiat Panda. It might be complex, and we are not sure we can make this happen.
What do you have against the Fiat Panda? It's a beautiful machine.
I used to have one when I was younger, but it has not the room to put a 4-liter Ferrari motor into it, right? At least mine didn't have this much space.
Next question from Divina.
This is an impossible question. Feel free to do not answer. He wants a news info specs date about V4000 and 3000.
No,
Specs.
Nice.
What we have is the V1200 right now, and the 1200 and the 4000 speaks the same protocol on the bus. So technically, putting a V1200 in an Amiga 4000 only needs to connect a few wires and a new FPGA load for the V1200. And actually, we did this as a side test project right now. So I think producing an optimized version for the Amiga 4000 is nothing which can be done this year, simply because Igor is 100% underwater producing the ordered V1200s, and I'm underwater with the V4. But the technology of the V1200 allows it to put into a CD32, the console, Commodore 32, or to put it actually in an Amiga 4000. So it's possible to do this. And we already did this. We have to.
So we can tell Divina to buy a V1200. No, I think no for the moment, but Vampire 1200 can be the base for Vampire 4000. Okay.
Yeah. With some minor changes on the jig file, you could run it in a 4000.
I don't hear.
Next question is by Divina also, and he's asking about the idea of creating an ASIC, a chip solution for the CPU, I think. Or I don't know what he's referring to.
Yeah, this is a dream goal, right? Like when I was younger, I always wanted to have you have Playboy girls coming to my birthday party. This didn't happen, but maybe this ASIC will happen. The problem, let's be realistic here. We right now have the luxury that we have an FPGA, because we can today do what I could never do at IBM. When I was working at IBM on some logic for a chip, you had a certain time you had to develop your logic, and then they made the chip development, and everything working by then came in the chip, and everything not working came not into the chip, and that was it. And then they made maybe half a year later another RIT. We called it RIT, you call it ASIC, and this was on the one they sold to the customer. So the first one was internal to test your chip, and if you had bugs in it, you had one more chance to fix it, and then it came to the customer. If I now look back on how many releases we did with the FPGA, we have the luxury to have hundreds of updates, and this is great. Without this luxury, we couldn't have developed this in our team. Impossible. And making an ASIC shop is very expensive. Yeah, we talk here hundreds of thousands of dollars, and I don't have the pocket money, to be honest, to make this. And I will have to get people borrow me money, or banks to borrow me money to make this happen. And I will only do this when I don't have the need anymore and not the interest to do an FPGA update, because I say, well, everything is now perfect.
A Kickstarter can help.
Yeah, but maybe I'm not the guy to borrow money from. I don't like. Yeah, I find this Kickstarter. I find doing something, right? Producing something which works, like the Vampire, and then giving to the people and say, okay, here, please pay me, and maybe also pay me $30 more than it cost me because I spent a lot of time to do this. This to me feels fair. I'm not so sure I have the moral stability to make a Kickstarter for something like that. Because, to be honest, if you make an ASIC, you might also shoot yourself in the foot. If there's a big bug in it, then you put $100,000 on the table and you only get crap, which doesn't work. If I make a mistake in my FPGA release, then I say, I'm too stupid. Another typo. Okay, fix a typo and make next day another release. Cost me nothing. Okay, 1 day lost. Okay, but maybe I need longer for the release. Maybe I need 2 weeks. So 2 weeks lost. But with an ASIC run, it's a lot of money burned. So it really only makes sense if you're very sure that everything is done and all your dreams are fulfilled. That you're fully happy with the audio chip, fully happy with the sprite machine, fully happy with everything. And you say, okay, this is Amiga I want to make. And then you make the ASIC run. If you are... But also we need to be clear here. ASIC is a different technology than FPGAs. So everything we do right now in the FPGA, you kind of need to port to to ASIC technology.
Mm.
So I don't know. Let's say you need to translate Italian to Spanish, right? It's similar, but there are still differences.
Okay.
And if you make a mistake in translating and by accident use the Italian phrase in the Spanish sentence, then okay, in a book it doesn't matter, but in an ASIC the ship will not work. So you really need to be sure you do this proper. And for example, let's look at the real guys. Intel has for this translation, for the process to the ASIC technology, an own team of 1,000 people. So this is not a job you do on a weekend, right? So
If you think about a Vampire Wolf 5, you think can have an ASIC, or you think on a better, bigger, on a more expensive FPGA?
I think an FPGA depends on the time frame. When do you want the V5? Do you want it next year or in 10 years? In 10 years, I say give you an ASIC. Next year, I will take an FPGA.
Okay.
I think right now, it makes absolutely sense to polish and to clean. I mean, if you do an ASIC, you can't change no more, right? And what I do right now, here the light is maybe a bit bad here. What I do right now, here looking at the blitter, you can't do no more if you already did your ASIC, right? If there's one game not working because the blitter has a minor difference, you never can fix this game. So I think this makes sense when you're done with everything.
Yeah.
And the Vampire right now on the market is a compromise between price and performance. It's not the cheapest FPGA. It's a middle FPGA, I would say. Like the list price of the V4 FPGA is $100, right? It's not cheap, but it's affordable. There are FPGAs which are a little more pricey, $200 or so, or $300, which are better. So we could, for sure, in the future, in a few years maybe, think about making a new Vampire which maybe runs twice as fast and uses a more expensive FPGA. I think this is a reasonable choice because it would still give us the freedom to tweak stuff and improve stuff. And a 100% performance upgrade would be awesome. No promise that we do this. I'm just thinking right now, right? But doing an ASIC step would literally mean I would need to take a year ASIC tuning work. I would need to have money coming in to get me living for a year. And at the end of this year, I would need to have $100,000 or $200,000 to get the ASICs baked. So literally, this is what is missing. And so this needs a lot of time, a lot of money, and this only makes sense, in my opinion, when what you start with is perfect already.
Okay. I think you answered this question.
Okay, so ASICs in the next 100 years.
I think it's possible, but maybe in 5 years.
5? Only 5. Okay, now next question. It's what is the difference between turtle mod and disabling caches?
For us, or
No, for the end user. For example, if I set the turtle mod with the V control program, or I just boot my Amiga, press the 2 mouse buttons and click on the checkbox to disable cache mods, is these two processes equivalent or not?
On Vampire, yes.
yes, it's the same.
It's the same.
Yeah. I mean, in reality, you can never turn the cache off on the Apollo core. The old 68Ks had a different designed caches, and the caches on the 68Ks had also negative side effects. For example, if you had floppy DMA, it could write into the memory, and the cache could never see this, and you would have stale data in your cache, and this then could lead to crashes or so on a processor with bigger amounts of caches. So 040 in the Amiga 4000, for example, introduced issues there because of this. And a way for the Amiga to solve this, or the Amiga developers, was turning off the caches and turning them on again after doing floppy operations. So you would flush the caches. And this basically made the Amiga slower than needed. And with the 080, our caches are a big factor of our speed, and they're also very big and very advanced. And turning off the caches would be like turning off the engine of your car. And we don't want to do this. And we try to solve the problems instead avoiding them. Right? The Amiga way was avoid the problem, simply turn the cache off and turn it on again. And our solution was to find a real fix or a real solution to this. So we designed our caches to be coherent. Coherent means that when the DMA writes into the memory, the caches automatically sees this. And when the CPU writes something to the memory, it always ends in the memory, and the DME can always see the latest data. So in other words, we try to solve the problem so that everyone in the system, every piece, knows every time the latest current data, which in return means we never need to turn off the caches because our caches are by design coherent. And for us, if a program turns off the caches, we try to understand why the program does this. Does it want to run slow? Or what is the reason? And our thinking or our interpretation is the program knows to have a problem when the caches are on, because then it's maybe too fast. And we then switch to turbo mode to help the program. So, or let's say it's the other way around. Programming on the Amiga is not easy. You have all these complicated chips in the Amiga, which makes the Amiga. And it's because it's a complex task, people like me or you or other demo coders could have forgotten to do some things. And because the Amiga 500 they were on was very slow, sometimes waiting for a certain event of the blitter could have been forgotten and didn't hurt much. Didn't cause a crash. But if you now have a faster CPU, forgetting to do this could have caused a crash, right? So if I walk over the street and close my eyes, I don't need to die if no car is coming. But depends on the situation. I could die on a different situation. So if there are no more cars on the streets, like CPU is faster, walking with closed eyes on the street could kill me or could cause a crash. So it's a similar thing here. And we try to see if a program walks with closed eyes, maybe we should slow down the cars to prevent the crash. So we try to be smart here and try to make the Amiga not crash when it normally would. It's our kind of way to solve this.
Okay. I like the analysis. Question from Dr. Procton. You may know him. His questions are 3D acceleration. We heard it's coming, but what's the plan? It will be...
The plan is always world domination. We started already with a 3D unit during the Natami time. So, as you know, every
some pictures
on the planet we wanted to do. Video in, video out, 3D acceleration, everything in the book. And, well, as you also know, part of our team were involved in the Cell ship, which is used in the PlayStation 3, which runs many games. So we had some, let's say,
You worked on
ideas, right? And so we saw how it could be done. And of course, the FPGA is not doesn't have the room to do something like the Cell. It's obvious. So there needs to be a compromise. But we had some ideas, and we put a lot of work on those. And all these ideas got kind of sidetracked because then with the vampire stuff, we focused on getting the vampire running and so on, and we were very busy. And now we are not so busy. Some things are finished, CPU is finished, FPU is finished, everything runs. So we did pull out our 3D routines out of the drawer. Maybe you've seen some of the texture mapping demos we did on the vampire. There was something like some animal faces rotating demo long time ago. The texture mapping, and so yeah, we have some ideas and we have also some logic working, but it's not sales ready yet. So maybe next year or maybe in November. I don't know.
Oh, November is near.
Okay. Do I go on with the next question?
Please.
Yeah.
Are the Super EGA feature complete? Will you become a book writer in the next month and write the new hardware reference manual?
This is a very important task. And I'm honestly much better in writing hardware than in writing documentation. I look forward to someone helps me to write a book like that. And complete they are not. The other day, Ollie from the Atari guys pointed out to us that the Atari OS has problems with the Amiga sound format, because the Atari format for 16-bit sound is different. And so we thought maybe easier to fix the solve this problem is adding a second sound format to our audio chip, which is cool because it also is used on the PC and makes talking PC games easier. So there are still new ideas coming, and we always look if we can help people make software easier this way, or make porting games easier, or it makes it easier to write video players, then we try to integrate features like this if it fits well into the Amiga context. So we still, I wouldn't say the hardware is closed 100%, but it's very mature. But it could be that tomorrow we have a super cool idea and say, wow, this feature needs to be in too.
This is the fun part.
But of course, right now, you see, oh yeah, you don't see it. It's not so, it's a little bit too bright here. Huh? You can't see it. It's Apollo OS. It's a new release. Yeah, we will probably, I don't know, tomorrow or so bring out the next release official, together with the new core version publicly. And I will also tomorrow drive to the PCB factory to pick up a new batch of these boards. So we focus on bringing out the release now to more people, and in parallel we work on the next release to be released probably in October. Hopefully improve something on the blitter even better, and so I have 2 or 3 games which don't look perfect yet, which I want to fix with this, and maybe similar games using the same effect also for demos or some fix. And also I spent a lot of money on buying tons of different wireless mice and wireless joysticks for USB, which I would like to get the protocol analyzed on the USB, and I hope, can't promise this, but I hope this with the next release, some of these wireless devices will work better with an Ampere. So we have there a certain roadmap, a certain plans we work on. Like you mentioned, this 3D thingy was evaluated by 2 guys on the team in the last month. So this we will also need to fit in our release plan. And in parallel, you're fully right. We need to document better the stuff we did. So there are the improved sprites and the improved audio features which need to be documented. As you might have noticed, Milky Tracker makes now use of these new audio features, so it can play directly on the new audio channel 16-bit. So we want to prepare documentation and programs using these features, and also take parts out of these programs, code parts, and publish them as, like you said, this is assembly instructions, like small snippets to say, look, with these 5 lines of code you can play a wave, and with these 10 lines of code you can do this and that. But this is a big to write this on.
Okay, next question from Danny PPC. It's about the Vampire V4 standalone. He says there are many good games that come out after a while without any errors. I think he is saying that they exit when they shouldn't. Others like Alien Breed 30 doesn't work well. He says, I want a compatible and reliable Amiga clone at least 99%. Will it ever be possible?
Well, we want to see. I mean, I don't know which core he uses. If he uses V4 core from the Amiga 32 from last year, which we shipped officially since all the time till this week, basically. Now comes out the second official version. I have put together with Juan a lot of work, and with John, the 3 of us, we try to measure the timing of the AGA. I mean, you have to know, the Amiga display is pretty complex. You have the copper, you have the planes, you have the glitter, you have different entities which together build the Amiga, and how to program is defined in the hardware reference manual. How they internally work is not 100% defined. So the thing is, you have to imagine this, you have like a cooking recipe for a cake, but they don't tell you how long you need to put it into the oven. In hardware, you have data coming in from the bus, and it goes to a certain piece of logic, and it comes out on the other side of the logic. And they tell the programmer, you put these values in, you get that result out, but the time it takes through the logic to work is not clearly defined for all the places. And for a picture to look just the same, you need to find this out. So if a copper starts an instruction, you know this copper instruction will change the color on the screen, the background color. This is clear, and this is defined how it's coded. But how long the copper needs to process this instruction, how long the information needs to take to get into the color registers, and how long the delay from the color register to the pixel on the screen is. This you need to measure. This is not written anywhere. And this is just a simple example. So if you measure this all and re-implement the delay in the correct way, then it looks perfect. If you don't do this, then funky things happen. that the copper wants to update a sprite, but this happens 1 pixel timing too late, and then the sprite is only half there or so. And then the games look not right, or something other strange happens. And for many games, the problem is that the turtle might not be turned on correctly. If this is not on, then CPU runs like 100 times too fast, and then also games crashes. So our goal here is to get the AGA 100% timing-wise right, plus the new features, but they all should be in timing correct. Then also all old games are right. So this is our goal, and we have worked night and day on this.
Okay, so it seems to me that a great part of your work is figuring out the times in which the custom chip operates, because that is not written anywhere. There is no official Commodore documentation about this.
Yeah, that's right. It's a bit of detective work. You write test cases and you look and you see, oh, what happens here? This, how can I explain this? So it's a little bit like solving puzzles or so, and figuring out how the internal logic really behaves.
I also remember a thread on the English Amiga board forum about undocumented chipset features, and I used some of them because the chipset sometimes behaves strangely in some ways. I don't know, and I assume that this must be a problem for you, that you are trying to re-implement to recreate the same logic and the same functioning of the chip. However, next question. I don't waste any more time because we're past midnight and we are running a little bit late. We don't want to waste your time and your sleep. This is a big question. I see the most talented developers busy with portings and contributing in Apollo OS.
He answered.
Okay.
The best.
There are 4 questions.
If all people are busy with developing Apollo OS,
Okay, I go on, and you will answer if you haven't yet. I see the most talented developers busy with portings and contributing in Apollo OS, and that's great news. But should you suggest the hobbyist coder how to quickly glimpse the vampire's power? Which is your advice going at low level? Already answered that. Basic dialects like Amos or Blitz, or scripting language like Hollywood and Arex. Where to start? Wikidocs, toolchains, dockers, etc. Pardon.
I think your RamJam assembly course might.
Yes, RamJam all the way. That's also my answer. 6080 and the MMX. Is the instruction set complete, feature freezed, or are you free to add new mnemonics?
It's a strange question, right? The instruction set wasn't changed since over a year, I think. So the instruction set, or let's put it the other way around. The people which define this instruction set have many years experience in writing Intel stuff using SSE or writing Altivec stuff for IBM. So I, for example, wrote the vector libraries for IBM in Altivec, which were like 10,000 lines assembly. And so this is, let's say we knew how these instruction sets work. which is an advantage if you want to develop a new one, right? You can reuse proven stuff which you know this is good, right? If you grew up with your mother and you looked how she cooked and you knew what dishes you liked, and if you knew how she cooked this meal, you knew how to cook a meal you like. At the same time, we also knew stuff which didn't work so easily, which was very complicated to develop in Altivec or nearly impossible, for example. And so with AMMX, we tried to also look for solutions which IBM couldn't do, or you couldn't do with IBM chipset. And we had the interesting part that people of our team, game developers, and also like Hendrik, who wrote the SIMD as a relation for the Riva video player, he worked on defining some of the video standards, you know, H.264, and so he worked. He's a professor on a university, and his job was defining these video standards. So he has had a lot of experience in video codecs, and when he used our instruction set, he said, okay. He also was an expert in Intel and PowerPC SIMD instruction sets. So he said he could do with our instruction exactly what he needed to develop a great video player, except what he always missed in the instructions was this and that and that. So he came already with ideas how to solve problems better than IBM could do it. And this was great feedback because we could, based on his feedback, improve the AMX instruction set to be more powerful than PowerPC's Altivec, for example, is for video decoding. And so every time we have feedback from a game developer, we took this back into our instruction set. So there are, especially in AMX, are a few instructions which make coding games easier. Few instructions which make decoding videos easier than Altivec can do it, for example. So maybe if we have some feedback from another developer which says, if you give me this instruction, then I don't know, the 3D game will run even better. We will of course be free to add new features to the AMX to enable more. Right now we are pretty happy with its content, and it's not bad, I think. It's a lot better than AMX from Intel was in the old days. Miles better. But if people have solutions or let's say programs they want to develop like a 3D game, and they can show us, if we add this new wonderful instruction, then this PlayStation game will run twice as fast or so. We will of course evaluate this and make this happen.
Okay.
We have just one last question from ZTK. It's a very generic question, and it's the last one. Could you tell us what the Apollo team long-term goals and plans are? The secret plans part, I love it. Without having to kill us after. What is the next milestone?
Yeah, so world domination is a long-time plan. You know this already. So we want to revive Amiga. This is the plan. And I think this can only go in two routes. So one route is the accelerators, which will enable the old trusty Amiga fans, which still have their machine, to continue to use it. So we have now the V1200, and which, as you know, can also run in a CD32. There will at some point obviously come out a version for the Amiga 4000 or 3000, but this will take time. And for those which want a new Amiga with these new features and maybe not have an old Amiga, the V4 is our way to help those people and to get more people again code on the Amiga. So our roadmap is here to continue to produce the V4. We want to increase the production. As mentioned, I will tomorrow fetch a new batch, and we have agreed now with the manufacturer that he will ramp up the production rate to be twice as fast as before. So, so this is for us very important to get the queue of people waiting done in the next weeks or months. And as mentioned, for us very important is, personally very important is that the compatibility to the old games gets to be perfect and as good as we can do it. And so I see here a lot of work being put into AGA in testing of we spent a lot of time in testing the copper instruction speed to get it as good as possible. I think we are very good now. And the new release is much better than the previous one. I'm right now for the coming release. I'm reviewing the blitter to correct an issue there, which you see in R-Type 2, for example. And I think our goal is here to get it perfect, to get it really as improved as possible, which luckily the FPGA allows us. We can iteratively improve the core. And for me, also important is to get the USB support better so people can use wireless mice or wireless keyboards. And yeah, so we have a clear roadmap of a number of upgrades we plan to do. Just takes time. And I hope that at some point in the future there will be thousands of Empire 4 owners which then have a perfect system where all the games run, which is fast. Maybe the 3D acceleration unit is even working, and which maybe, I can't promise this, right? But we're working on this and we're planning for this. It might not happen, maybe something goes wrong, but we hope that you then have capabilities to play like PlayStation 1, 2, somewhere in the middle, some like these games. But hopefully there will be more developers making use of this, and we will see new games, new demos, cool new stuff.
Perfect. We can stop here. We thank you very much, Gunnar, for your time. It was a pleasure for us to have you here. I hope you enjoyed the meet.
I did, and I thank you a lot. I mean, it's great to be with true Amiga fans. It makes me feel home. And I'm sorry that I elaborated some of these answers, but you might hear that. I mean, this is important for me and for our team. The whole vampire thingy and the revival of the Amiga is very important for us. And I hope you see this. We don't do this to make quick money or so, because we do this for a matter of love. We are very passionate here that we really hope to finish, and we are proud that we came so far with the help of all the Amiga fans.
I just want to thank you, Gunnar, also for daily availability on the Discord Apollo team chat. I see that you always answer to the people who have problems, or just ask everything about from the Apollo OS channel and the V4 channel, as well Apollo team forum. I see you are very active. That's what I see. And I see it's a true labor of love. For what I understand, I am a customer because I have a V600, and I just bought another one, the 1200 from Igor. It should arrive in a few days. I hope. And so I just want to say, I'm very happy with your work. For me, my vampire is almost perfect. Uh, I don't need an ASIC version. Is the product I always dreamed. I can play Doom on my RTG screen. It's incredible on my Amiga, and above all, I can do it at a reasonable price because I don't have to look for a rare processor or whatever else. The only problem is the availability of the Vampire cards. I had to stay in line for a lot of time for the V600 and also for the 1200. I see there are people who buy the card and then resell. I don't know what is your position about this behavior. I think it's not very correct. Speculating on your work, but that's how money rules, probably. And I just want you to thank you for the vampire cards, for the project, but above all for the passion you put on this project, and for the answers. I know I bother you chat. I'm sorry for that. Probably asking stupid questions, but you are always so kind with me. So thank you again.
I thank you. I thank you for the kind words. It's very good. I have to admit, I'm usually working like 10 hours a day on the Vampire progress, but this hardware development, I write. I work very iteratively. I make a small change, which I can overlook. Then I make a compile, and compile usually takes me 25 minutes. And then I see if I did was good or bad, and so I work every day, and usually during the 25 minutes I already code something new, which I then test, or I answer in the forum. So I have during my normal day work, which lasts long, always 10 minutes here, 10 minutes there time to answer questions. So this is no problem.
Okay, we can go to the bed. Thank you.
I'm
Thank
sorry.
you very much for being here, for the Apollo core. That it's fantastic. I have 3 vampires, so this
Wow.
is a testament. And I'm the one that both the Wu4 and Wu1200 the same day.
Cool.
If you remember, it was a strange thing. But it's a testament to the work and to the faith of people who put their hands on these products is because they are fantastic for Amiga fans.
I thank you guys. I thank every Amiga fan out there, and I thank my team, the Apollo team, for being here and helping. I mean, you right now only see me here, and I mean, of the people in the team, I'm maybe the longest one in, but it's more than me. There's a lot of very, very, very good guys, which without their great help and passion and ideas and testing, this never would have been able to finish. So thank you all, guys. Thanks.
Thank you.
Thank you, Gunnar.
Ciao allora. Thank you very much.
Ciao. Good night.
Ciao.